Hi everyone, now we are at unit number 5, Multivariable Calculus, lecture number 5. Homogeneous function of two variables, definition. A function f of x comma y is said to be the homogeneous function of degree n, degree n in x and y, two variables. If f of lambda x comma lambda y should be lambda power n into f of x comma y. That means this function is given to us f of x comma y. Instead of x you substitute lambda x and instead of y you substitute lambda y. If lambda terms are completely coming out, then it is a homogeneous function of degree n. So lambda power something. So that is called uh, the power n. The n is said to be degree of such homogeneous function. This lambda a should be more than 0. It can be any real number but more than 0. Lambda belongs to real number system which is more than 0. Okay. Note, if f of x comma y is a homogeneous function of degree n, then it can be expressed as, so you can write these functions like this. That means you can take x power n common, then it will be a function of y by x. You can express as a function of y by x, or you can express as a function of x by y if it is a homogeneous function of some degree. Okay, look at some examples. Then with this I will tell you. Look at first one, where it is homogeneous function or not. If it is a homogeneous function, what is the degree of this? Let us verify. So f of x comma y is given, then compute what is f of lambda x comma lambda y. So f of lambda x comma lambda y is lambda x whole square, okay, lambda x whole square plus lambda y whole square. Wherever y x, there I am writing lambda x. Wherever y, there I am writing lambda y. That's it, nothing else. And here lambda x plus lambda y. Lambda x plus lambda y, square root of. And numerator completely lambda square will comes out, and denominator root lambda will comes out. That means lambda for 1 by 2, or you get root lambda. So what you will get, x square plus y square after taking lambda square is out from the numerator, and denominator square root x plus y. So root lambda is out. So look at this is nothing but what? So lambda square, so minus 1 by 2. 2 minus 1 by 2, 3 by 2. So lambda power 3 by 2. Lambda power 3 by 2. And this is nothing but what? It is a function of f of x, the old function. Look at separated. So this is nothing but given function, right? F of x comma y. Like that you are separating. So lambdas are completely came out and power 3 by 2. Therefore it is a homogeneous function of degree n. Okay. So it is a homogeneous function. Homogeneous function of degree 3 by 2. Homogeneous function of degree 3 by 2 because power is 3 by 2. Okay. And look at the note, if f of x comma y is a homogeneous function of degree n, then it can be expressed as either function of y by x or function of x by y. Look at this function f of x comma y, particular x comma y here. So f of x comma y is x square plus y square divided by root of x plus y. Okay. Then if you take out numerator, one x square is out, denominator root x is out. So x power 3 by 2, right? So x power 3 by 2. What will remains? 1 plus y by x whole square. Isn't it? Numerator I am taking x square is out. And denominator root x I am taking out. So therefore 1 plus y by x. Look at it is a function of y by x now clearly. Look at. So therefore, so x power 3 by 2. That's why look at here x power n. Look at the first one. X power n in the note x power n. So here n is 3 by 2. So this can be written as x power 3 by 2. X power 3 by 2. It is function of y by x. G of y by x I am writing. Only y by x term should be present. Y square, y cube term should not be present. Only y by x term should be present. Like 1 plus y by x whole square divided by 1 plus y by x. So y by x is another variable, like, so is a function of y by x now. Or you can take y square is out, no problem. If you take y square is out, denominator root y you take out, then what will get? Y power 3 by 2, and here x by y whole square plus 1 divided by y x by y plus 1. So it is a function of x by y. You can express in both. So if it is a homogeneous function, then we can express like this. Similarly here also, yeah, this one, yeah, is it a homogeneous function? So f of lambda x comma lambda y. What is this? So lambda x plus lambda y. Wherever x, there you write lambda x. Wherever y, there you write lambda y. Okay, and lambda x whole square. Okay, plus root of lambda y. Okay, numerator lambda is out. What will remain is x plus y. And what about denominator? Denominator lambda square x square root lambda is there. So lambda square x square and root lambda into root y. So complete lambda square you cannot take out, right? Look at maximum. So if you take lambda square is out. So x plus y. Look at the denominator. Look at the denominator. In this denominator, if you take lambda square is out, here divided by lambda square. So lambda power minus 1 minus 3 by 2 will remain. So completely lambda square, completely lambda term you cannot take out. If I take root lambda is out, what will remain inside? 1 by 2 is out. So lambda power 3 by 2 here. Lambda power 3 by 2 into x square plus here root y. So therefore this is, it is not equals to lambda power n into some, again same function f of x comma y. It is not equal to like that. So you are unable to separate f of x comma y. Therefore it is not homogeneous function. Okay, so therefore it is not homogeneous function. It is not homogeneous function. Not homogeneous function like this. Okay, similarly homogeneous function of three variables now. Three variables. A function f of x comma y comma z is said to be homogeneous function of degree n in x, y, z. If same story again, lambda x, lambda y, lambda z should be f of, that one is lambda power n into again whole function f of x comma y comma z, where again lambda is positive real number. Note, if f of x comma y comma z is a homogeneous function of degree n, then it can be expressed as, so if you take out x is out, then y by x, z by x will get. So it is a function of y by x and z by x. Similarly here, if you take y is common, it is a function of x by z and z by x by y and z by y. If you take z is common, x by z, y by z, like that. It can be expressible like this if it is a homogeneous function of degree n. Look at examples. First one, is it a homogeneous function or not? So again same story, f of lambda x, lambda y, lambda z. Okay, now it is root lambda x divided by root of lambda x whole square plus lambda y whole square plus lambda z whole square. Okay, then numerator root lambda is out and root x is as it is, and divided by denominator lambda square you take inside, so lambda will comes out, and inside x square plus y square plus z square. So therefore this can be written as, so again lambda power minus 1 by 2, isn't it? Lambda power minus 1 by 2 root x divided by square root over x square plus y square plus z square. So therefore finally you will get it is lambda power minus 1 by 2, okay, f of x comma y comma z, old function. Okay, so therefore it is a homogeneous function of degree minus 1 by 2. So therefore conclusion is, it is a homogeneous function of degree minus 1 by 2. So degree minus 1 by 2 homogeneous function. Similarly look at this one. What about this? Let us verify it. F of lambda x and lambda y, lambda z. Now this is lambda x plus lambda z into lambda y, okay, divided by lambda x whole square plus lambda y whole square. Okay, now numerator look at lambda x into lambda square is there, so completely lambda is not coming out. Okay, lambda square z y divided by lambda square out, x square plus y square, denominator completely coming out but numerator is not coming out, therefore it is not equal to lambda power something into again same function f of x comma y comma z. It is not able to write like this, therefore conclusion is, therefore it is not homogeneous function. It is not homogeneous function. So this is about homogeneous function. So based on this result, one famous theorem, that is Euler Theorem, that we are going to discuss. So once if you know the homogeneous function, then you will understand the theorem. Now look at the theorem number 2, Euler's theorem. So here the requirement is let f of x comma y be a homogeneous function of degree n in x and y. That means it is a two variable function which is of homogeneous function of degree n. So this is a requirement. Then conclusion. Okay. If the first order partial derivatives of f exist, first order partial derivatives means fx and fy like that. Then x into fx dou f by dou x plus y into dou f by dou y. This result is exactly equals to n into f. What is n? Degree of homogeneous function, and f is the given function. So without computing what is dou f by dou x, so it means what? In other way of writing this one is x into fx, right? Fx means dou f by dou x plus y into fy is equals to n into f. To find this, what I have to do actually? First of all, f is given to you. Then you have to compute what is fx. Okay. Then what is fy? These two values you need to compute. Then x into f of x plus y into f of y, you have to simplify this. Then you will get n into f of y. Definitely. So without computing this result, directly you find what is the degree of this homogeneous function. Then n into that function. That's it. So without computing this, directly answer is n into f. So that is Euler theorem. Similarly, second result, if the first and second order partial derivatives of f are continuous, then x square into dou square f by dou x square plus 2xy dou square f by dou x into dou y plus y square into dou square f by dou y square is equal to n into n minus 1 into f. Again same story. Without computing all these things, directly n into n minus 1 into f, its value, this entire thing value. That means it can be written as like this. X square fxx, okay, double derivative, plus 2xy, what is that? First with respect to y, right? So fyx, okay, plus y square into fyy is equal to n into n minus 1 into f. N into n minus 1 into f. Okay. Here fyx or fxy, both you can write, no problem. Why? Because look at here. If the first and second order partial derivatives of f are continuous, they are continuous. So once they are continuous, then f of fxy is exactly equals to fyx. That means order doesn't matter. With respect to x you can do, or with respect to y you can do first. Doesn't matter, both can be equal. This is true provided if the second order partial derivatives are continuous. So therefore here 2xy, fyx you can write, or xy you can write, your wish. If the homogeneous function of three variables like f of x comma y comma z be homogeneous function of degree n in x, y, z, and first order partial derivatives of f exist, then the result is x into dou f by dou x, y into dou f by dou y, z into dou f by dou z is equal to n into f. Again same story. Here since it is a function of two variables, therefore dou f by dou x, dou f by dou y. Here three variables, therefore dou f by dou z will come extra. So n into f, that is the result. Let us have some problems related to that. Look at this one. So prove that x into dou f by dou x, y into dou u by dou y, x into dou u by dou x plus y into dou u by dou y value x square plus y square by x plus y. So we need to prove that. So first method, without approaching to Euler's method, what you have to do is u of x comma y is given to us, right? U of x comma y is given to us, x square plus y square divided by x plus y. This is given to us. Just to compute what is dou u by dou x. Take it exercise, okay? Compute this. Next we compute what is dou u by dou y. So both unknowns you can find. So after evaluation of that, then substitute these two values here. That means x into dou u by dou x and y into dou u by dou y. Simplify this one. X into dou u by dou x plus y into dou u by dou y. Simplify this. You must get this one. Which one? X square plus y square divided by x plus y. This one will get. This is the first method. Okay. Second method, by using Euler, without computing that partial derivatives, you can do it. Okay. So therefore, first what is given to us? U of x comma y. Okay. So u of x comma y is x square plus y square divided by x plus y. Okay. Now is it homogeneous function or not? Let us verify. So u of lambda x comma lambda y. Okay. So lambda x whole square plus lambda y whole square divided by lambda x plus lambda y. Okay, now one lambda, so lambda square in the numerator and lambda in the denominator. So finally what will get? X square plus y square is in the numerator and denominator x plus y. Okay, x plus y. So finally you will get as, so therefore this is, or simply is equals to lambda into f of x comma y, sorry, u of x comma y. Okay, lambda into u of x comma y. So nothing is there, means power is 1. So therefore u of x comma y is homogeneous function of degree 1, is homogeneous function of degree 1. Okay, by Euler theorem. Euler theorem, yes. What is the conclusion? X into dou u by dou x. Since here u is homogeneous, therefore in the equation you have to involve u only. Okay, y into dou u by dou y is equals to n into f. This is value n into f. But what is n? N is here 1 into f. Sorry, n into u here, not f. Yeah, I should make a note of it. The function, same function only, how to write n into u. Here f is u, right? N into u. So 1 into u. So 1 into what is u? U is nothing but x square plus y square by x plus y. Look at. So this is the power of Euler theorem. So hence proved. That's it. Okay. So this is without you computing the partial derivatives. You can do this one by using Euler's theorem. Okay. Next one. Problem number 2. Yeah, look at this. If u of x comma y is cos inverse of x plus y divided by root x plus root y. Okay. Then prove that x into dou u by dou x plus y into dou u by dou y value minus half times cot u. Okay. So look at now what is given to us. U of x comma y. This is cos inverse x plus y divided by root x plus root y. Root x plus root y. Now let us verify where is a homogeneous function or not. Okay. So u of lambda x comma lambda y is equals to cos inverse of lambda x plus lambda y divided by root of lambda x plus root lambda y. Okay. Now this will be cos inverse of lambda is out from the numerator, lambda of x plus y divided by root lambda is common and denominator root x plus root y. Okay, perfectly separated. Okay, but this you are unable to write as, look at lambda power 1 by 2 or lambda power 1 by 2 x plus y by root x plus root y. Root x plus root y. Now this is not equals to lambda power n. Actually lambda should comes out, right? But here lambdas are not coming out of the cos inverse. It should come out of the cos inverse. So it is not coming out, right? So cot inverse of lambda power n into u of x comma y. That means not equal to lambda power n into u of x comma y. But what is u of x comma y? That means it is not equals to lambda power n into u of x comma y. That means what is u? Cos inverse of x plus y divided by root x plus root y. Root x plus root y. So like this. So you are unable to express this entire function like this. Therefore it is not a homogeneous function. Okay. So therefore u of x comma y is not a homogeneous function. Is not a homogeneous function. Okay. So once it is not a homogeneous function, therefore Euler theorem I cannot apply. Okay. But I need to prove this. Then I am modifying this. Look at how I am modifying is u of x comma y is given to us. U of x comma y is equal to Remember, if the function is homogeneous function, then only I can apply Euler theorem. Otherwise, I cannot apply. So u of x comma y is equal to cos inverse of x plus y divided by what is there, root x plus root y, root x plus root y. Okay. Now send cos to this side. Then what will get? Cos u. Just I am writing u. U means u of x comma y. Okay. So cos u is equal to x plus y divided by root x plus root y. Okay. So let v is equal to cos u. I am assuming v is equal to cos u. Okay. Which is x plus y divided by root x plus root y. Okay. I am assuming this cos u value is equal to some v, or v is equal to x plus y divided by root x plus root y. Now let us take, see, u is a function of x and y, so therefore v is also a function of x and y. Okay. So therefore v is equal to, let us take x plus y divided by root x plus root y, and now verify whether it is a homogeneous function or not. Okay. Yeah. So yes, what is v of x comma y? X plus y divided by root x plus root y. Okay. Now what about, is it homogeneous? Yes, it is homogeneous only, right? By looking at it, you can guess. So lambda x lambda y, let us verify. So lambda x plus lambda y numerator. Okay. And the denominator lambda x plus root lambda y. Okay. And numerator you take out, lambda is out, x plus y, and denominator is root lambda is out. What will remain? Root x plus root y. So finally this will be lambda power 1 by 2. What is this? V of x comma y, right? V of x comma y. So therefore v of x comma y is a homogeneous function of degree 1 by 2. Is a homogeneous function of degree 1 by 2 by Euler's theorem. What I can write? X into dou v by dou x. Remember, actually I need to prove x into dou u by dou x. Look at the problem. I need to prove dou u by dou x. But here v is a homogeneous function, then v satisfies Euler theorem, right? That's why x into dou v by dou x plus y into dou v by dou y is equals to n into v. But what is n here? N is 1 by 2. V as it is. Okay. V as it is. So now in the next step you replace what is v. Dou by dou x of what is v? Go back. Look at here. V is equal to cos u, right? V is equal to cos u. I am replacing v is equal to cos u here. Cos u. Why I am replacing? Is it required? Yes, it is required. Why? Because the result is in terms of dou v by dou x and dou v by dou y. But what I want, look at problem. The result should be dou u by dou x and dou u by dou y. I need to prove that in terms of u because u is given to us. That's why compulsory you have to substitute back. Okay. Plus y into dou by dou y of what is there? Cos u. Okay. And this one is supposed to simplify. This is equivalent to half times what is the cos u. Yeah. So x into what is u? U is a function of x and y, right? U is a function of x and y. Therefore, it is a both function of x and y. Therefore, what is dou by dou x of this? First of all, derivative is minus sin u, and u derivative with by chain rule dou u by dou x, because u is a function of two variable. Okay. First cos u derivative, next u derivative, plus y into again cos u minus sin u, and u derivative dou u by dou y. Okay, is equal to half times cos u. Now let us take minus sin u common. Then what will get? X into dou u by dou x plus y into dou u by dou y. Okay. So after taking minus sin u common, then send minus sin u to right hand side. Then what will get? Already half cos u is there here, of cos u divided by 1 minus will be there and sin u here. Okay, and x into dou u by dou x plus y into dou u by dou y is equal to minus half times cot u. Cot u. That's what we need to prove actually, right? Look at into cot u. Hence proved. That's it. So this is a way of doing this is a way of applying the Euler's theorem, provided the function is homogeneous function. Look at, so if you don't want to apply this Euler's theorem, then how to proceed this? Again same, u is given to you, find out what is ux, find out what is ux, okay, and what is uy you compute. But these two, computing these two is very difficult because it is cos inverse of this thing. So first of all, cos inverse formula you should know. After that, u by v method you have to apply. So it becomes very lengthy one. Finding ux and uy will become very difficult. So here we are, without finding partial derivatives by Euler theorem, we can find the result x into dou by dou x plus y into dou by dou y. By Euler theorem, we can do like this. Understand? So next one. Next problem number 3. If v of x comma y is this, where it is not equal to 0, it is defined, then evaluate x into vx plus y into vy value and all these values. Look at one by one. So first one, solution, first one. By looking at this immediately, you have to strike out its problem belongs to Euler theorem. Before that, it should be homogeneous function, right? So directly I am doing v of lambda x comma lambda y. V of lambda x comma lambda y is equal to what is lambda x whole cube plus lambda y whole cube, okay, divided by lambda x plus lambda y. Okay, so overall lambda cube common in the numerator and lambda common in the denominator, overall lambda square will come, right? Lambda square x cube plus y cube divided by x plus y. So it is completely separated. So that means it can be written as lambda square into again v of x comma y. So therefore it is a homogeneous function of degree 2. Therefore it is, or v is a homogeneous function of degree 2. It is a homogeneous function of degree 2. Homogeneous function of degree 2. Okay. So once it is a homogeneous function of degree 2, then we can apply Euler's theorem to the function v only. So therefore by Euler theorem, so therefore by Euler's theorem, what we can write, x into dou v by dou x, because v is a homogeneous function, plus y into dou v by dou y is equals to n into v. Okay, but what is n here? N is 2. N is 2 into v, right? So therefore this only x into vx will get, so therefore x into vx plus y into vy is equals to 2 into v. 2 into v, or v is equal to what? X cube plus y cube divided by x plus y. That's it. So its value is this much. Okay, first one is over. This is the first one. Next, similarly, second one. And look at the second one. X into dou square v by dou x square, y into dou square v by dou x dou y minus dou v by dou x. So it is not Euler's theorem second statement. Euler theorem second statement, 2 into xy term will be there, right? What is second statement? Euler theorem second statement, x square dou square v by dou x square plus 2xy term will be there, 2xy dou square v by dou x dou y, okay, plus y square into dou square v by dou y square. So this kind of terms. So this is n into n minus 1 into f. But here 2 into xy term is not there. Look at second result. So therefore you cannot apply this one. Understand? So it's not of applying Euler's theorem second statement. Or if you don't know anything, then compulsory you have to find out what is v dou square v by dou x square. Already v is given to you. Find out what is v double x, double derivative of v. And next dou v by dou x of dou v by dou y. Find out this value. Already v is given to you. Then find out what is dou by dou x and substitute in this, you will get the value without applying any theorem, Euler's theorem like. So therefore, what I am doing is by looking at this one, by looking at one, or let us take this one as a one. Okay, this one as a one, not this one. Okay, so look at one. One implies apply partial derivative both sides with respect to x. Why I am doing this one? Because of, look at here, already dou v by dou x is with me. If I dou v by dou x is with me. If I do one more time with respect to x, dou square v by dou x square I will get. Okay, but x is as it is. X will remain same. Okay, but here x square term is there. That's why I am not proceeding this one. Only x term is there in the question. Because in the question only x term should required. But if you want to apply Euler's theorem second statement, x square term will be there. Therefore, you should not apply this. Then how to generate x into this double derivative? Simply by doing this one with respect to x again. If you do this one with respect to x, dou v by dou x into dou v by dou y. So therefore again same you are getting same. So let me apply a partial derivative with respect to x to this equation number 1. Then what I will get? So therefore dou by dou x of, so that is ideology. So x into dou v by dou x plus y into dou v by dou y, okay, is equals to dou by dou x of 2 times v, where v is a function of x and y. Okay, now this is, let me write again. So dou by dou x of x into dou v by dou x. Now let us proceed a partial derivative with respect to x. Now apply to this term first. So dou by dou x of x into dou v by dou x. First this term. Next again dou by dou x of y into dou v by dou x, dou v by dou y. Okay, is equals to 2 will comes out dou v by dou x. Because v is a function of x and y. First with respect to x derivative 1. Okay, and dou v by dou x as it is. Plus next x as it is. Dou by dou x of dou v by dou x. What will get? Dou square v by dou x square you will get. Okay, u method is over for this first one. Plus second one, with respect to x you are doing, therefore dou by dou x of y is 0. 0 into dou v by dou y. Plus now y as it is, what will get? Dou square v by dou x dou y. Dou x dou y. So this u method is over, is equal to 2 into dou v by dou x. Then what will you get here? So dou v by dou x plus x into dou square v by dou x square. Okay, plus here y into dou square v by dou x dou y. Dou x dou y is equals to 2 into dou v by dou x. So now this is, look at x into dou square v by dou x square. Look at exactly this terms only present in the question. Y into dou square v by dou x dou y. Okay, is equal to, so 2 into dou v by dou x minus dou v by dou x. So one time will remain, right? So this is dou v by dou x. So you bring this one to this side. So what will you get? X into dou square v by dou x square plus y into dou square v by dou x dou y minus dou v by dou x. So this value I want actually, right? So this value how much? 0. That value is 0. So look at the question, second one. So this is, so this value we need to compute. So this value is supposed to compute. So this value. So therefore this value how much? Answer is 0. So similarly third question in that. Look at third one. Y into there again y square terms are not present. So again same one you take. Instead of doing partial derivative with respect to x, you proceed partial derivative with respect to y. Okay, same thing. So for this third statement, so for the third question, do partial derivatives, do partial derivative to both sides of 1 with respect to y. Okay, take it exercise, complete this. Okay, take this one as exercise, take this one as exercise. Same like what I have done just now for second problem. Okay, simply you apply both sides dou by dou y of equation number 1, then you will get the required result. And look at the fourth question here. What is the fourth question? Now look at x square term is present. Now you can apply Euler Theorem second statement. X square dou square by dou x square, 2xy term is present, y square is there. So simply what is that? N into n minus 1 into f. So therefore this result here only I am writing. So what is this result? It is n into n minus 1 into f. Okay. Sorry, f instead of f here, what I need to write? You have to write here, it is v. Okay, it is v. Because v is a homogeneous function of degree. How much? 2. So therefore substitute n is 2. So 2 into 2 minus 1 into v. So therefore what will you get? 2v you will get. 2 into this entire thing. So therefore this value is 2 into v. Understand? 2 into 2 minus 1, that is 2. So this is the result of the fourth question. Okay. So this is just by using Euler theorem only. If you don't want to apply Euler theorem, then proceed and find out what is what is Vx, what is Vy, and what is Vxy, and all these things you have to compute and you have to substitute here and you have to simplify. And you have to substitute here and you have to simplify, the required result you will get. Okay. Next, problem number 4. If w is equal to sine inverse of this, then find x into dou w by dou x plus y into dou w by dou y plus z into dou w by dou z value. Same Euler theorem, theorem number 3, but it is a function of 3 variable. Again, we look at how to proceed this kind of. Okay. So first of all, is it homogeneous function? Let's verify. W of lambda x, comma, lambda y, comma, lambda z, right? And this is equivalent to sine inverse of, right? Sine inverse of lambda x whole square, okay, plus lambda y whole square plus lambda z whole square divided by lambda x plus lambda y plus lambda z. Okay, now simplify. So this will be sine inverse of, what will get? Lambda square numerator common and denominator lambda is out, so one lambda is out. Okay, therefore what will get? X square plus y square plus z square divided by x plus y plus z. But this is not exactly equals to, lambda power something into again w of x comma y comma z. It is not like this, right? Therefore it is not a homogeneous function. Therefore it is not equals to lambda power n. What is w of x comma y comma z? Sine inverse of, what I mean to say is lambdas will not comes out from the sine inverse. That's why it is not a homogeneous function by x plus y plus z. So therefore conclusion is, so therefore w is not a homogeneous function. Homogeneous function. So once it is not a homogeneous function, then what to do? You are having two choices. One is find out what is dou w by dou x, because already w is given to you. Compute partial derivative. Next, compute what is dou w by dou y. Next, compute what is dou w by dou z. Partial derivative is compute and substitute in this value. In this value substitute, then simplify it, you will get its value. That is one way. Second way, by modifying this function w is equal to sine inverse of this. By modifying this function, you may apply Euler's theorem. But how to modify this? Look at. So therefore, this we can write. Look at here. Let so v is equal to w of x comma y comma z, or instead of writing v is equal to, let us write w is equal to sine inverse of x square plus y square plus z square divided by x plus y plus z. Okay, then sine function to this side, then what will get? Sine w is equal to what will get? X square, okay, plus y square plus z square divided by x plus y plus z. Okay, now this one sine w is equal to this, right? So therefore sine w, so therefore let assume that is some v, so v is equal to sine w is equal to x square plus y square plus z square divided by x plus y plus z. Okay, now let us verify this v of x comma y comma z. Now v is a function of three variables, right? Because v is equal to this entire function x square plus y square plus z square by x plus y plus z. Therefore v is a function of three variables. So this is equal to x square plus y square plus z square divided by x plus y plus z. Now let us verify for this function v is a homogeneous function or not. Okay, now so therefore v of lambda x comma lambda y comma lambda z. Now substitute back, so lambda x whole square plus lambda y whole square, right? Next lambda z whole square divided by lambda x plus lambda y plus lambda z. Okay, now lambda power 1 will comes out overall, so lambda power 1 into what will get? Directly I am writing v of x comma y comma z. Therefore what is the conclusion? So therefore v of x comma y comma z is a homogeneous function of degree 1 that means n is equal to 1. So therefore conclusion, so therefore by Euler's theorem what we can say? By Euler's theorem, x into dou v by dou x, look at x is satisfying, that's why I am writing x into dou v by dou x. Previously w is not satisfied, that's why x into dou w by dou x I am not writing. Okay, since v is satisfying, v is a homogeneous function of degree 1, therefore with respect to v I am writing x into dou v by dou x plus y into dou v by dou y, because v is a function of three variables, plus z into dou v by dou z. This value is n into f, n into v. And substitute here, what is n? N is 1 here because it is a homogeneous function of degree 1. 1 into v. Okay, 1 into v it is. So let me continue here only. Yeah. So therefore x into dou v by dou x plus y into dou v by dou y plus z into dou v by dou z. This value how much? 1 into v. Okay, but what I want result in terms of w. Look at the question, look at x into dou w by dou x, y into dou w by dou y plus z into dou w by dou z. In terms of w I want, so therefore in terms of w I need to find out the results. Therefore what is here, what is v value here? Look at this, v is nothing but what? Sin w. Therefore substitute here, so x into dou by dou x of v value sin w, okay, plus y into dou by dou y of sin w plus is equal to n is 1, so v is equal to sin w. Okay, now let us simplify. So x into what is dou by dou x of sin w? See, look at w is a function of three variables, therefore sin w is a function of three variables. It is a function of three variables, sin of x plus x comma y comma z. So dou by dou x is makes sense. Don't write dou by dou x of sin w is 0 because there are no x terms here. Not like that. W is a function of x comma y comma z, therefore dou by dou x is makes sense. Now what is dou by dou x of sin w? Sin w derivative cos w first. Okay, and w derivative with respect to x is dou w by dou x, like this, plus similarly y into cos w dou w by dou y plus z into cos w dou w by dou z is equal to sin w. Okay. Next one, let us take cos w common in LHS. So what do we get? X into dou w by dou x plus y into dou w by dou y plus z into dou w by dou z. This value how much? Cos w I'm taking right hand side, left hand side common and send to right hand side. So sin w by cos w will get sin w by cos w. Therefore it is nothing but tan w. So therefore final result is x into dou w by dou x plus y into dou w by dou y plus z into dou w by dou z. So this value is tan w. That's it. So this what is meant by Jacobian? Few properties about Jacobian. The first one, the Jacobian arises naturally when there is a coordinate transformation. Coordinate transformation means sometimes in integral evolution, if the integral is typical one or difficult one, then what we have to do? We can go for transformation, right? Like x is equal to r cos theta, y is equal to r sin theta. Like that we can substitute. Or some x plus y is equal to t, or x square plus y square is equal to t. That kind of substitution we can make, like x plus y is equal to t, this kind of, or x is equal to r cos theta, y is equal to r sin theta. So this kind of substitution we can make, right? That means what? Old coordinate is xy, now new coordinate system is r comma theta. So this is r comma theta, now old one is xy. Now x comma y coordinate system is transforming to r comma theta, like that. So when there is a coordinate transformation, then Jacobian is naturally useful there. You will learn about this Jacobian in deep in the next semester, that is in integral calculus. Okay, just we are discussing the basic concepts of Jacobian in this class. Next one, coordinate transformation is generally used in double integral evolution and as well as triple integral also, double integration and triple integration also, and triple integration, both. In both we can use this Jacobian. Suppose that a region R in UV plane is transformed into a region R dash in the XY plane, okay, R dash in the XY plane by equation of the form x is equal to function of u and v, y is equal to function of g and v, like this. What I said, t is a function of u and v here, okay, because x plus y is equal to t. I am substituting this, right? That means what? T is a function of x comma y, like this. So similarly, f is a function of u and v, and that function I am calling some x. For example, u plus v is equal to x kind of, and u minus v is equal to some y kind of, like that. So this is a transformation. So u comma y coordinate system is transforming to x comma y coordinate system. Okay, like this. So this is u comma with Cartesian plane. Now this is transforming to Cartesian xy plane. Okay. Now u comma v coordinate system. This is u axis, this is v axis, and this is x axis, this is y axis. So u comma v coordinate system is transforming to x comma y coordinate system, like that, by under these transformations. Now we are going to evaluate the same integral here instead of evaluating here. Why we are transforming this? Because of the difficulty of integral. The integral is very difficult one, then we can make a substitution. That means instead of evaluating in this region, we are going to evaluate in this region because everything is changes. So in the UV plane, so these are region of integration. For example, double integration 0 to 1 and 0 to 2. What does it mean? For example, x is varying from 0 to 1 and y values are varying from 0 to 2. That means what? It is a region now. That region is this, for example. And if you change the coordinate system, then accordingly the limits also will change, right? According to that limits, this is a region. That's what I am telling actually. Okay, so in this region now we are going to evaluate. So that is, so therefore in this case the Jacobian is most useful. Look at now the definition, original definition. The Jacobian determinant, or simply Jacobian, of the coordinate transformation x is a function of u and v and y is a function of u and v. It is defined like this. So it is represented like this. J means Jacobian of the old coordinate u and v. Old coordinate u and v. So now it is defined like this. So x is a function of u and v, right? So once x is a function of u and v, then dou x by dou u makes sense.
Dou x by dou u makes sense, and dou x by dou v makes sense because x is a function of u and v. Similarly, y is a function of again u and v. Therefore, dou y by dou u, dou y by dou v. So it's defined like this. Okay, dou of x comma y divided by dou of u comma v. All these are representations. These two are representations, and this is a definition. That means what? Determinant of, it is not modulus, it is determinant. 2 by 2 matrix is determinant. So xu means dou x by dou u. Okay, x suffix u, and x suffix v means dou x by dou v. Similarly, this one and this one. So this is a Jacobian definition. The Jacobian is nothing but it is a determinant. Okay, the Jacobian measures how much the transformation is expanding or contracting the area around a point in R as R is transformed into R dash. Just now I said this is R, let's say this is R and this is R dash. Now this is old coordinate system, this is old coordinate system, this is a new coordinate system. In old coordinate system, this is a region. In the new coordinate system, this is a region. So Jacobian will tells you, that means it gives you a number. For example, it is giving a number 20, for example, let's say determinant is 20. It means what? 20 units it is expanding. Previously, for example, if it is 1 unit, now it is 20 units. That means what? 20 units it is expanding. For example, if the Jacobian is minus 2, that means 2 units it is shrinking, contracting. Shrinking means decreasing the area. So like that. So Jacobian means it measures how much the transformation is expanding or contracting the area around a point in R as R is transformed into R dash. Region R is transformed into region R dash like that. So that is the geometrical meaning of the Jacobian. Okay. Now same thing Jacobian for 3 variables. The Jacobian determinant or simply Jacobian of the coordinate transformation, x is a function of 3 variables and y is a function of 3 variables and z is a function of 3 variables. This is u, v, w. Okay. Let me write here. It is u, v, w. u, v, w. Okay. u, v, w. All are functions of 3 variables. Now the Jacobian is defined like this. So dou of x comma y comma z divided by dou of u comma v comma w. Okay. So now same thing again. First row for x, dou x by dou u, dou x by dou y, dou x by dou w. Same x v, x y, x w. And second row for second variable y. So dou y by dou u, dou y by dou v, dou y by dou w. Same y u, y v, y w. Next third row for z. Again it is a determinant. Okay, 3 by 3 matrix determinant. The Jacobian of the transformation measures how much the value now, because it is 3 variables are present here, 3 dimensional. So 3 dimensional means it is value. How much the value near a point in is being expanded or contracted by the transformation from UVW space to XYZ place space. That means this one. Okay? This is UVW space. This is XYZ space. Now this is old value. Okay. Under this transformation, it became the region of integration is this. That means this is mostly useful in trivial integration. So x limits, y limits, z limits. That means dx, dy, dz. This you will see in next semester. Don't worry about this. Just the basics of before entering into this kind of integral calculus. Okay, these are basics. Now old one in UVW, in this region you have to evaluate the integration. Now in new Cartesian system XYZ you have to evaluate in this system. That means the region is here is value because it is 3 dimensional. Previous one is 2 dimensional, therefore it is a area like that. Next one definition, functional dependence. Let us take two functions u and v, both are functions of x and y, be differentiable functions in some region R. Okay, if the condition is the Jacobian is vanish. So j of u comma v, or simply this one I can write j of u comma v or dou of u comma v divided by dou of x comma y. Okay, because u is a function of x and y, v is a function of x and y. So therefore dou u by dou x. Okay, and this is in the first row dou u by dou x and dou u by dou y, and second row about v, dou u by dou x and dou u by dou y. Okay, you can represent like this also, j of u comma v or simply dou u comma v by dou x comma. Simply denominator independent variable you have to write. X and y are independent variable here. If you know x and y value, for example, look at this. U is equal to some x plus y. That means what? U is a function of x and y. And u is a function of x and y like this. For example, just for example I am explaining. That means what? U is a function of x and y. That means f of x and y like this. Okay. Similarly, v is a function of x and y. That means g of x and y. Okay. Now in this, if you know x and y value, then I can find what is v value. Therefore, x and y are independent. So these two are independent variables. And this is dependent variable. Similarly, v is a dependent, x and y are independent. So independent variable you have to write in a denominator, and dependent variable you have to write in a numerator like this. Dou of v comma v will be dou of v. So that means indirectly it means what? Jacobian vanishes in R, in the region R. It is 0 means what? Jacobian vanishes. Then there is a relation between the function u and v. That means they are dependent, u and v are dependent. Already I have seen in first unit. In the first unit already I have seen. For example, look at this. The rank is 0. Sorry, depth is 0. The determinant is 0. That means what? Indirectly. Example, let us look at this 1, 2, 1 and 2, 4, 2 and 2, 4, 2. For example, this kind of matrix is present. Definitely depth is 0. Why? Because look at first row, this is R1 and this is R2 and this is R3. So clearly your R1, 2 times R1 is nothing but R2, right? That means what? R2 is depending on R1. So by using the transformation R2 minus 2 times R1, what happens if you place it R2? That is completely 0. This is completely 0 because it is multiple of this one, right? Therefore 2 minus 2 0, 4 minus 4 0, 2 minus 2 0. Therefore this row completely vanish. So this becomes 0. And the same transformation for R3, here what I will get? R3 minus 2 times R1, if you placing it R3, then again these 3 become 0. These 3 become 0. Because they are dependent. Now look at det is 0. That means what? Indirectly determinant is 0, all the 3 rows are dependent rows. If the rows are independent, then det is never 0. Same ideology here. So if the determinant is 0, that's what they are depending. Rows are dependent. That means what? The corresponding functions are dependent. That's what I said. They are dependent. X and y, u and v are dependent. If determinant is vanished. Same ideology. Okay. Now let us look at some problems related to the same concept, Jacobian and related, function related things. Okay. Now look at this. What is given to us? Two transformations are given. First transformation u of x comma y, which is x plus y, and v of x comma y, which is 2 into x plus y. So without proceeding anything, first what is given to us? Two transformations given to us. Does u and v are related? Question. So clearly the observation I can say that v is nothing but 2 into u, right? Is that v is nothing but 2 into u. What is v? 2 into x plus y. 2 into what is u? X plus y. Look at satisfied. Therefore this is a relation without going for Jacobian. So does u and v are related means yes, they are related. Over. Answer is over. Yes. Yes, they are related. Yes, they are related. But if you want to approach through Jacobian, you can approach like this. Second method. So according to the concept of Jacobian, if the Jacobian vanish, then compulsory there is a relation. See here the functions are very simple, that's why the observation we are telling that yes, they are related. Sometimes function may not be simple, these functions. Then how to decide? You keep on verify all kind of combinations, all kind of relations, all kind of calculations. But that is not so easy. That's why we have to move to the Jacobian. If Jacobian vanish, then that is a sign of existence of relation between the corresponding functions. So therefore here let us look at the sign whether relation exists or not. So therefore for that Jacobian of u comma v we have to complete. That means what? The first here what I need to write? Dependent variables. So u and v are dependent variable and corresponding independent variables are x and y. That's for x and y we have to write in denominator. What is the definition now? Ux, right? Dou u by dou x. Next dou u by dou y. Next dou v by dou x. Next, dou v by dou y by definition. So now what is dou v by dou x? Dou v by dou x. Use this. What is dou v by dou x with respect to x? Derivative is 1. And y is 0. 1 plus 0. 1 plus 0. 1. And dou v by dou y with respect to y it is 1. And next one it is 2. Next it is 2. Now what is the depth now? Look at 2 minus 2 0. 2 minus 2 0. Therefore Jacobian is vanished. So therefore Jacobian vanish. So therefore u and v are related. So therefore by observation what I can say, v is equal to 2u. That's it. So this is the relation. So now I can say that u and v are related.